Hello students, I am Dr. Sanjeev Ponia. In yesterday lecture, we discussed about the basics of digital electronics. There we discussed about the number systems, Boolean algebra, logic gates, Boolean expressions. Then we discussed about the logic circuits and we see that there are two basic logic circuits. First one is combinational circuit and second one is sequential circuit. In this, we discuss about the combinational circuit in detail in last lecture. Today, we will discuss about the sequential circuit. So let's start. We will discuss about the bistable device, latches and flip-flops in the sequential circuits. Then in sequential circuit, we will discuss the transfer modes, that is synchronous and asynchronous transfer mode. In the last, we will discuss about the trade range, that is edge trade range and level trade range. So we discussed earlier that what are the sequential circuits. When we were studying about the combinational circuits, or we discuss the logic circuits from the start, then we discuss the difference between combinational circuit and sequential circuit. So sequential circuit has memory. As we discussed at that time, sequential circuit has memory. And what's the need of memory? The need of memory is because next signal, next output signal, or the output of the circuit for the next stage is based on the last output and current input. So this is the reason that we want memory device for the sequential circuit. We study that in combinational circuit there is no need of the memory because output of the device is completely based on current input. So this is the block diagram of a combinational circuit, where this is the combinational circuit. In this there is no need of the memory. In this combinational circuit only we are adding a memory device. We are adding a memory device, and the input of this memory device is the last output of the circuit, as well as output of this memory device goes to the input of the circuit. So this is the representation of the sequential circuit. So this was the difference between combinational and sequential circuit. Now, after understanding the sequential circuit, we will try to understand that how we can implement the memory. Means we will implement that how we can make the live memory, or what are the different elements when we have to design a memory. Our first purpose is memory design. Means we will try to understand that what happens in inside the memory, and later we will discuss the operations based on the content of the memory is going to be changed. So when initially we will start from the bistable device, as we discussed in the starting also, that here in sequential circuit we will discuss about bistable device, then latches and flip-flops. So these are three things we will discuss in sequential circuit first. So bistable device. This is a device. Bistable device is a device that has only two values. By represent two. By represent two. So a device, this is a device that has two states. Two states is either high or low, either high or low, and we know that when we are saying high, it represents 1, and in case of low, it represents 0. So a device that has only two values, that is called bistable device. Means two states only, either high or low, where the values are either 1 or 0. Means this is a device where the value of this can be either 1 or either 0. It is directed. Actually, the value of the device is going to be changed. Maybe at a time, the value that is stored in that device is 0, and maybe next time we have to change this value from 0 to 1. So there should be a procedure to change the values in the device. So the value is going to be changed based on the input signal as well as clock pulse. We will discuss about the clock pulse within a moment. So now we are discussing that the values of the device is going to be changed based on either input signal, means whatever the values we are giving, or there is a different signal that indicates or that tells the device that now change the values. So as I told you that there are two states. First one is set and second one is reset. This is set, or this is also called high, and this is reset, so this is also called low. So there are two states only, set and reset, high and low, and values can be either 0 or 1. Means there is a device where the or output can be either 0 or 1. And one more interesting thing, that there are two input, two outputs, in which one output has the either value 1 and another output has the value 0, means reciprocal to each other. Here, when I was discussing about the states, it means whatever the value it is going to store, either 0 or 1, either 0 or 1. Here, I am discussing about the values at the output, that there are two values, either I can use this one or I can use this one. And bistable devices are of two types. First one is latches and second one is flip flop. Now we will try to understand the difference between latches and flip-flop first. So latches is a bistable device. Latch is a bistable device where we have any of the value that is 0 or 1, and value is going to be changed based on the input value, as we discussed before some time, that the two values are going to be changed based on input signal and clock pulse. So when the value is changed by input signal, in that case that is called a latch. And the time between the current state and the next state is the propagation time. Means the current input, this is for an example current input, this is output at a stage, suppose at stage 1. Now we are changing the value, so time taken to change the value is the propagation time, is the time when we changed the input and the time we get the output. So this is the time taken by the latch. This is called propagation delay. Propagation delay. Implementation of latch is to design flip-flop. To design flip-flop, this should be flip-flop. This is by mistake, so I am extremely sorry for this. The implementation of latch is used for flip-flops. So the state changed based on input values. The delay is of the propagation time delay, and the implementation of the latch is when we have to design flip-flops. So these are the characteristics of a latch. Now, suppose this is a latch, we can design the latch based on other gates also. Based on other gates also. Here I used X or X NOR gate. X NOR gate. Sorry, X NOR gate will be when I will put over here. So this is X, or let me change rabbit this also, and this is rabbit first. Why it is not running? Or it will run now. Yes. So we discussed about this, that the latch change its state based on input values and it implements latches. And this is the block diagram of latch that represent it. So this latch is implemented using NOR gate. So this is a NOR gate based on which we implement this latch. Gates can be different. It can be NAND, it can be NOR, but one more thing, that it cannot be AND or or not. Means we cannot use the basic gates. Only universal gates are going to implement latches. So this is the block diagram of a latch. Means these are two inputs. The one input is going as an over here. This is the output of first gate. This is the output of the second gate. We are feeding this output as an input in the gate. So this is the reason we told I told you over there that we have to use the output of the circuit as an input for the next stage. So here we are using this output for the next input, and over here also you can see that output of this gate we are using the input for this gate for the next stage. So suppose this is a current state, this is next state. We have two inputs I1 and I2, I1 and I2. So there can be four combinations. This is 00, 01, 10 and 11. These are four different combinations. Then I took two values for 00, that is 0 and 1, two values for 01, two values for 10, and two different values, that is 01 for 11. These two values shows the change in the input. As I told you that state of the latch is going to be changed based on the input value. So this is, suppose this is the earlier or the current value and the next value is 1, based on which the stage is going to be changed or the output of the circuit is going to be changed when input value is going to change. We are not discussing about the next stage, that what will be the output of the next stage. Means it will be 1 or it will be 0. My purpose is only to tell you that when we have the input values 0 and 0 0 0 1 1 0 and 1 1, then based on current stage, how the value of the next stage is going to be changed in case of latch. So this is the basic implementation of a latch, and you can see that in this we are using the output of the last stage as an input of the current stage. Now flip flop, from last slide you can see that there are only two states, and the values are going to be changed, or it is directed by either input signal or the clock pulse. When it is going to be changed based on input signal, then it is called latch, and when the value of the circuit is going to be changed based on clock pulse, then it is called a flip flop. The latch is going to implement the flip-flop, and here the flip-flop change its state based on the clock pulse as we discussed just now. The delayed means next stage will delayed by a time that is triggering time. That is triggering time means how much time it takes to trigger from one state to another state. If you will see over here in the latch, then the time delayed is the propagation time when the value is going to be changed. But in case of flip-flops, the delayed time is the triggering time. We will discuss about the triggering time also, or triggering also within a moment. The implementation of the flip-flops are used to implement a memory. As we saw that a latch is going to implement the flip-flop, and a flip-flop is going to implement the memory. So we can try to understand this in this way. Suppose this is a latch, this is a latch, this is going to implement the flip-flop, and the flip-flop is going to implement the memory. So when we have a memory, then it consists, or basic component of the memory is a latch. So we can say that memory contains either flip-flops or latch where it saves the data, and we studied that it store only one value at a time, means it's a bistable device, so it can store either 0 or 1, means one bit at a time. Suppose I want to store a 8-bit data, then I want 8-bit to store this data, and I know that 1 bit is going to be stored by one flip-flop, so I want 8 flip-flops to store this data of 8-bit. So this is the basics of memory design, that how we can implement the memory and what's the basic concept in behind designing the memory. Now, types of flip-flops. There are different type of flip-flops, and these are based on the input as well as on the output, that what's the input we want to give and what's the output we want to take. Means based on flip-flop, the change in the values is going to be happen. So there are 5 types of flip-flops. First one is SR flip-flop, second is JK flip-flop, third is D flip-flop, and fourth is T flip-flop. While this is a master slave flip-flop that can implement any of the flip-flops, or we can say that this flip-flop contains this flip-flop contains 2 parts, so there are 2 flip-flops in this. We will see this also. So the output of flip-flops, suppose this is a flip-flop J, this is a SR flip-flop. There will be 2 input and there will be 2 output. As I told you, one output is Q and second output is Q bar, but these two will be complement to each other. Suppose this is 0, then this is 1, or for an example, this is 1, then in that case, other output is 0. So this is the basic property of the flip-flop. And there are always two inputs to change the value of the flip-flop. As I told you earlier, that to change the values of the flip-flop, we need a clock pulse. So there should be also a clock pulse based on that values is going to be changed in the flip-flop. So now we will see only the overview of this because we have studied the flip-flops in detail. And second thing, there is no need of the flip-flops. So we will not go in the depth. The representation of SR flip-flops are, there are two inputs as I told you. So one input is S and second input is R, and we are getting two outputs, that is Q and Q dash. It is represented by Q dash so that it will be easy to understand that this is the complement of this Q. And we know that complement of a number, suppose this is a number, then complement of A is going to represented by either A bar, or sometimes we represented it by A bar. So if the value of A is 1, then the value of this is 0. If the value of A is 0, then the value of this is 1. So there are two outputs. Those are complementary to each other. There are two inputs, S and R, and third one you can see that this is a clock pulse based on which the values are going to be changed in the flip flops. So this is SR flip flop, this is JK flip flop, this is D flip flop, and this is T flip flop. You can see that here is only one input, that is D, and in this also there is one out input, that is T. So what we will do, we are giving the same input, so to we will combine the second input with the first input so that value of both the inputs are same. Suppose we are giving 1, then 1 is over here and 1 is over here also. 1 is over here also. And if I am giving a value 0, then 0 is on the first input and its same value, that is 0, will be on the second input. But in this case, on the second input, we are giving the reverse value. You can see from here that we implement or we use a NOT gate between these two inputs. So when I am giving a value 1 over here, then on another input, means second input, I am giving 0, and when I am giving a input 0 over here, it means I am feeding a value 1 at the another input line. So this is the basic of flip-flops. Now the next flip-flop, that is master slave flip-flop. We will see only the concept of master flip-flops only, not in the detail. So there are two flip-flops we have to use in master. So this is first flip-flop is said to be master flip-flop and second flip-flop is said to be slave flip-flops. I represent this by SR flip-flop means it means that we are going to implement this using SR flip-flop. We can implement this using JK flip-flop also. So what happens when I am giving a clock pulse to both the flip-flops? These are the inputs, the same input, the same input I am giving to the second flip-flop also. Same input means the output I got at the first flip-flop. The same I am giving to S, and the other output that I get on Q bar, we give the same to the R. So this is the reason that I am saying that same input we are giving to master and slave flip-flops. But you can see from here that in case of clock, if I am giving a clock over here to first, then to the second flip-flops, I am giving a reverse flip-flop, a reverse in signal. For an example, over here I am giving a signal 0 to this clock pulse. It means I am giving one signal over here. Sorry, this is 1, so reverse of this is 0. So this is 0 means at a time only this flip-flop will work. And when this is 0, then in that case this flip-flop will not work, and when I am giving a 0 input at this clock pulse, then I will get a 1 output, means in this case only this flip-flop is work. So in master slave flip-flops there are two flip-flops, but at a time only one flip-flop works. So this is the reason that this is called master slave flip-flop. At a time either master is going to be worked or slave is going to be worked. So these two are based on the clock pulse, and when the clock pulse value is 1 in one flip-flop, then it is 0 in the another one, and when its value is 0 in the first flip-flop, then second flip-flop has value 1. So the flip-flop triggers in the reverse order. This is the reason they are called master slave flip-flop. Now let me check that what is the next. Okay, next is transfer mode. So there are two type of transfer modes. As I told you that the control signal, that is clock, the value of this circuit, the value of flip-flop is going to be changed based on the clock. So clock can be of two types. First one is synchronous and second one is asynchronous. When I am using a clock in which the values of all the flip-flops change at the same time, then this is called synchronous mode. For an example, I have 5 flip-flops. I have 3 flip-flops, and forget about the input. I am not discussing about the input over here because our target is to discuss the clock only. So suppose this is a clock pulse when I am the when I am feeding this clock pulse same to all the flip flops at the same time. This flip flops also takes this clock pulse, this also takes this clock pulse. So when we all the flip flops use same clock pulse, it means when I am changing the value of the clock pulse, all the flip flops work simultaneously at the same time. And in asynchronous mode, the flip flops, all the flip flops does not work at the same time. It means suppose this is one flip flop, this is another flip flop, this is second flip flop, this is third flip flop, and this is the clock pulse. This is third flip flop, and these are the clock pulse of these flip flops. Then the same clock pulse, this is the clock pulse, same clock pulse does not change the values of the all flip flops. Maybe this clock pulse is connected with one output of this flip flop, and the clock pulse of next flip flop is going to connect with the next flip flop output. So the value in this flip flop is going to be changed based on the output of the first flip flop. The value of the third flip flop is going to be changed based on the output of the second flip flop. So in asynchronous mode, in asynchronous mode, the output of one flip flop is going to feed as an clock to the next flip flop, or the value of next flip flop is going to be changed based on the earlier output of the flip flop. So this is called asynchronous mode. So the data can be transferred in two modes, that is synchronous mode and asynchronous mode. When the same clock pulse is going to used in all the flip flops, then it is synchronous mode. And when at different time the clock pulse is used in the flip flops, then it is, or when same clock pulse is not going to implement in all the flip flops, then it is asynchronous mode. Now triggering is of two types. In last one, that is in transfer mode, we discuss that when the values can be changed, when the values can be changed based on the mode, means there is two things. One is mode and one is triggering. Mode decide that all the flip flops will work at the same time or not, and this in triggering, it decides that when the value of the flip flop is going to be changed. So there are two basic ways in which values can take the place. So it can change either at the age, or it can change the value at the level. So suppose this is a clock pulse that we are feeding to the circuit then these are called edges. These are called edges. This is called a edge. These are this is called a level. This is called a level. This is the positive level. This is the positive level of this signal, and this is the negative level. This is the positive edge. This is the positive edge means when the value is going to change from minus to minus to plus, then it is called a positive edge, and when the value is going to change from plus to minus, then this is called a negative edge. So the values can be changed either at positive edge or at negative edge, either on positive level or on the negative level. So on positive edge, on negative edge, on positive level or on negative level. So this is the change in the value. Suppose we are saying that this is a positive edge tree ring, it means it contains a triangle over here. It contains a triangle over here. And when with triangle it contains a circle, bubble or a not gate, it means it's a negative as triggering level. Negative as triggering level. And in case of level means positive level and negative level, this is represented by simply a clock pulse, and in the case of negative level, it is going to represented by a bubble or a circle in this line, in the clock line. So this is the representation of the triggering, that the triggering is which one. This is a edge triggering or this is a level triggering, and if this is edge triggering, then it is positive edge triggering or it is a negative edge triggering. In the case of level also, it represents that this is a positive level triggering or this is a negative level triggering. When there is a bubble over here, it represents that this is a negative level triggering. So we discuss about the triggering. So at triggering, the value is going to be changed in the flip-flop or we can say in the memory, but at the time of the mode, it's decide that how the value is going to be changed in the flip-flop. These are the transfer modes. It tells that what is the way in which the values is going to be changed, and triggering decides that when the value is going to be changed. So in the revision of the digital electronics, as we discussed that before starting the computer architecture, we have to revise the digital electronics, and whatever the topics we want, I cover or I revised those all topics over here. So we discuss over here. Let me summarize once more. First, we discuss about the number system. First, we discuss about the number systems. that what is a number system and what are different type of number system. In types of number systems, we discuss about binary number system, about decimal number system, octal number system, and hexadecimal number system. Here we discuss that the base of the binary number system is 2. It has only two numbers, that is 0 and 1. In decimal, base is 10, means it contains 10th number from 0 to 9. In octal, base is 8, means it has 8 numbers from 0 to 7. And in hexadecimal, it contains 16 numbers from 1 to 9. It contains 60 numbers from 1 to 9, and after that A, B, C, D, that represents 10, 11, 12. Then we discuss the conversion of the number system, that how we can convert a decimal number system in different, that is binary, octal, and hexadecimal. Over there we discuss that how we can convert in any number system into the decimal. We discuss this also. Then we discuss then how we can convert a number system in different number system. For an example, I want to convert a hexadecimal to an octal. Then I told you that first we will convert this number into the decimal, and then we have to convert this decimal number system to octal. There are some other direct methods also, but we did not discuss over here. So in the number system, we discuss all these components. After this, we discuss that is Boolean algebra. Boolean means two, means this is a algebra that is concerned with only two values, 0 and 1. After understanding the Boolean algebra, we discuss the laws of the Boolean algebra, where it contains associative law, complementary laws, and De Morgan's law. Like this, we discuss all the laws and some direct expressions also, those we can use to solve the equation or Boolean expression. Then we discuss that what is Boolean expression, that contains all the variable, and after understanding the Boolean expression, we discuss that how we can simplify these Boolean expressions using Boolean laws or K-map. And finally, we conclude that K-map is the best technique to minimize the Boolean expression. So number system and Boolean algebra, we discuss all these things. Third, we discuss logic gates. In logic gates, we discuss about three basic logic gates, that is AND, OR, and NOT gate. After this, we discuss two universal gates, that is NAND and NOR. These are called universal gates because we can implement any of the circuit or any of the gate using these gates. So this is very important, and the questions is also, many questions are also based on this universal gates. Then we discuss about the derived gates. Those can be derived or those can be made by using these two, that is basics and universal gates, or using basic gates. In logic gates, we discuss about this. Then after logic gates, we discuss about the digital circuits. digital circuits, that there are two type of digital circuits. First one is combinational, second one is sequential. When there is no need of the memory, then this is called combinational circuit. In this, we discuss about the adder, half adder and full adder. We discuss about both half adder and full adder, and we discuss that how we can implement a full adder using the half adder. Then we discuss that how we can implement a subtractor, or we can perform an subtractor operation. After this, we discuss multiplexers and demultiplexers. Where there is only one output, then this is a multiplexer. When there is only one input, then this is a demultiplexer. Then we studied in combinational circuit about the decoder and encoder, where more than one input and more than one output. So in combinational circuits, we discuss about adder, subtractor, multiplexer, demultiplexer, decoder, and encoder. And in digital circuits, we study about the sequential circuit also. Sequential circuits are those circuits those have memory, because the output in the sequential circuit also based on the last output. So this is the reason that these circuits contains memory. Here we discuss that what are bistable devices. Means devices those contains only two values, either 0 or 1. Then we discuss that what are latches. Means these are used to implement flip-flops as, and the values are changed based on the input only. The propagation delay is the delay only when the value is going to be changed from 0 to 1 or 1 to 0. Then we discuss about the flip-flops in sequential circuit, that is SR flip-flop, JK flip-flop, T flip-flop, D flip-flop, and in discuss master slave flip-flop in the last, that at a time either master will work or slave will work, because we are implementing a not logic between the clock pulse of master or slave, and at a time either master flip-flop will work or slave flip-flop will work. And we saw that the flip-flops are used to implement a memory. After completing the digital circuits, we discuss about the transfer modes, and when the value of the flip-flops are going to be changed, when all the logic devices or flip-flops change the value at the same time, then this is a synchronous mode, or in simple words we can say then that the change of the value based on same clock pulse, and in asynchronous mode the change of the values is based on the output of the earlier flip-flops. Means all the flip-flops does not change the values at same time. Then we discuss about the triggering that there are two types of triggering: edge triggering and level triggering. Means the value of the clock pulse is going to change from to negative, positive to negative, or at the level that is at high level or at low level. Triggering is a method that tells that when the value of the flip-flop is going to be changed, as transfer mode tells that how the values of the flip-flops are going to be changed. These things we all discuss over here. And last two topics last two topics, that is shift registers, we will discuss we will discuss completely in unit 1 and unit 4. The complete unit 4 is based on our memory. We discuss this in digital electronics also, but here in computer architecture we will discuss all these type of memories, that is main memory, auxiliary memory, that is secondary memory, associative memory, cache memory, virtual memory, and then relations of the different memory, that is memory hierarchy in detail in unit 4. And about the shift registers we discuss in digital electronics also, that is left shift registers. Means when the values in the register is going to change from right to left, this is called left shift register. When the values of the register is going to change from left to right, then this is a right shift register. In this there are logical shift and circular shift. Means left circular, left logical, left right shift, and right life. Means in shift registers there are logical left shift, logical right shift, or circular right shift, circular left shift. Means these are of four type: left, logical, left, logical right, circular left, and circular right. So these four. In logical left, only and only the values of the register is going to be changed from right to left. In logical right, from left to right. In circular left, the values is going to be changed from right to left, but the leftmost value is going to change from this bit to this bit. Means last bit is going to change from last to first. And in circular right, the it is from left to right, but the last bit, or we can say first bit, is going to be changed from this position to this position. Then arithmetic shift. In arithmetic shift, it contains different type of shift based on the arithmetic operations, that is addition, multiplication, subtraction. So these are different type of shift registers, and we will study these shift registers in the unit first. So I think this is the complete thing we required in computer architecture. So we discuss all the things. Now in next class we will start computer architecture, in which we will discuss register transfers and memory operation That's the first part of unit first. So thank you. Thanks a lot. I hope that you will revise more digital electronics so that it will be more clear for us to understand computer architecture. Thank you. Thanks a lot.